Hi everyone, logarithms, the change of base rule. So today we'll talk about the change of base rule, taking logarithms in base, power law of logarithms, logarithm in bases other than 10 or e, change of base rule with base e, and most importantly, exact, to understand what does it mean to give exact solution. The change of base, reminding you that the base, this would be the base over here. In previous exercise, you should have proven the base 10 case of the chain tatam that we just saw in the previous video. So here it's log in base B of A. We can change the base from B into C by doing log in base C of A over the log in base C of B. So that is the formula we'll use. Here is the proof. We need this rule to evaluate logarithm in bases other than 10 or e. So first a bit technique. So log in base 2 of 9 changing to base 10. That would be log in base 10 of 9 over log in base 10 of 2, which is log 9 over log 2. And that is approximately 3.17. And same goes for changing to base e. So reminding you base e is ln. So ln 9 over ln 2, which is approximately the same number in both cases. This would be the exact solution, or that ln 9 over ln 2. And this would be the approximated or rounded to 3 significant figure. So if it says give the exact solution, it means give it, in this case, ln of 180 over ln 5. Otherwise, we can calculate that using the calculator, which is using this button there next to the shift in the calculator, and then using the arrow till we find log A of B. And then we get this screen where we put, in this case, the base first, 5, and then adding a comma, 180, and then you'll get the solution using the calculator, but you'll have to round it because it will be a number that doesn't terminate. So here you can practice a few more. Let's do that one. That is log of 0.067 over log 3, and here we change it from base 3 to bases of 10, or base of e, that would be ln 3. Those questions are medium level, maybe even harder. So when do we use the change of base? You see here we have, in this case, an expression, but the bases are not the same, so we'll change that, both of them, to be base of n. So that would be log n of n over log in base n of m times log, let's do that, so the power of 2, so let's put it here, log 2 log in base n of m. So we can already see these two will cancel, and log n of n is 1 because n to the power of 1 is n. So, and this is 1. So we get the answer in this case, it's 2. Here, base 4, base 2, base 16, 64, 4, even all of them are powers of this, powers of 2, powers of 4. We'll have to use the change of base rule. So in this case, I want everything to be base of 2 to the minimum number so that would be base 2 of x2 cubed over log base 2 of 4, which log in base 2 of 4 is 2, plus log in base 2 of x to the power of half equals 8. So we've seen this is 2. And let's continue here. So we get 3 log in base 2 of x over 2 plus half log of x equals 8 in base 2. Let's continue. Let's multiply everything by 2. So we get 3 log base 2 of x plus log in base 2 of x equals 8. 4 base 2 of x equals 8 dividing by 4. Log in base 2 of x equals 2, meaning x equals 1. Something went wrong here. Let's look at it together. So we change the base here into 2's. That looks good. And that is half log 2 to the term, looking great. And this multiplying. This is 16. Leave it. So, okay, and this would be 4. And this will be x equals 2. Okay, let's take a look at this one. Given x equals 3 in the base of 3 of y squared, express y as 81. 81, it clicks me fast, that is 3 to the power of 4. Let's work with that. So let's start with that x equals 2 log base 3 of y. So I need everything to be in base y. So let's change that. Let's already do it x over 2. And we're left with log in base y of y over log in base y of 3. Using the change of base rule. Log y of y is 1. So what do we get here? Log of in base y of 3 equals, let's do it longer, more steps, times x over 2 equals 1. So we can log of the term in base y of 3 equals 2 over x by multiplying by 2 and dividing by x. Now I want that to be log in base y of 3 to the power of 4. So I'll multiply both sides by 4. I get 4 log in base y of 3 equals 8 over x. And here I get log in base y of 3 to the power of 4, 8 over x. So log in base y of 81 is 8 over x. So those are hard or medium to hard level questions, but when do we use the change of base rule? We have to know that when the bases are different, then we want to use the change of base rule. And here we have the final solutions. So we talked about what is exact value, okay? So it's not the rounded number. It would be looking like log 7 over log 2. That would be an exact solution. Or log in base 2 of 7. Change of base rule, taking logarithm in bases. Okay. And thank you for listening and good luck.